Alright, in this video, I'm going to cover 2.3 families of functions and transformations and symmetry. Okay, so we're doing 2.3. Okay, so the okay, last time I gave the what the original translation and vertical translation, right? So the today I'm gonna introduce the other transformations, and then I'm gonna explain symmetry. Okay, give me a second. Sorry. So yeah, I forgot to resume the recording. Okay. So there, first one is reflection about the y-axis. What happened to the graph, the function f of x if we reflect the graph of f of x about the y-axis? Okay, reflection, the y-axis. Okay, so then we got this, right? This is then equation of f of x will be changed to f of negative x. It makes sense. You see, the only what change um, from f of x to the f of negative x is what? X value, right? Because the sign of x value is will be opposite, right? With the same y value. Because these two graph has the same y value, but their x value is their sign is different, right? Positive and negative. That's why we replace x by negative x. And then the other one is a reflection about the x-axis. Okay, so reflecting this one about the graph of f of x about the x-axis, then we got this, right? Okay, so this graph of negative f of x. You see, they have the same x value but different sign of y value, right? So we put the negatives because f of x is nothing but y. I told you so many times, right? So just plug in, I mean, you know, just putting negative sign in front of f of x, that means making the sign of y value to negative, okay, to opposite. So the other one is this reflection, combination of these two reflections. Reflection about the y-axis and the reflection about the x-axis. That is called reflection about the origin. Okay, so that's the okay. Then we got this, right? Okay. Then we once we reflect the graph of f of x about the x y-axis, we're gonna get f of negative x. Then reflect the graph of f of negative x about the x-axis, we get the negative sign out of f. So we got this. Now, Next one, is the origin. Yeah, so origin, what it means, right? Origin is 0, 0, right? Okay, so this is example, but textbook doesn't only cover the reflection about the x-axis. Okay, and then yeah, only cover this. So we'll see. For the text, yeah, so it's the example 3. Okay, so see the example 3, the textbook. Yeah, we see A. Okay, so f of x is defined as x squared, and then g of x is defined as negative x squared. All right, so then I told you the very first step is to express g of x in terms of f of x, because we know the graph of x squared, which is square function, which is parabola. So this is equal to negative f of x. Okay, so we know the graph of f of x, and then we want to plot the graph of negative f of x, which is a reflection about the x-axis, right? So the graph of f of x is this, and then reflecting graph of the parabola about the x-axis, we got this. Okay, so that's a reflection about the x-axis, right? Okay, so now what about b? Okay, b. So f of x is given by x cubed, and then g of x is negative x cubed. Yeah, negative x cubed is nothing but negative f of x. Right? So the graph of x cubed is this. Okay. So why graph of x cubed is this? Yeah, so yeah, I covered in 2.2, so please go back to 2.2, okay, if you wonder that. And then the f of x, negative f of x. See, negative f of x is a reflection about the x-axis. So reflecting the graph of f of x, then we got this. Right. Okay. So now we learned the objectives 1 through 4, right? So now we're gonna start the real problem. Okay, so now the that's the start in 2.3. Okay, so we are ready to see uh, real problems in 2.3. Okay, so all right, see example 6. Okay, so the question, yeah, use transformations to graph each functions. Okay, so two functions are given, example 6. So y is equal to negative 2 times x minus 3 squared plus 4. Yeah, it looks like complicated, right? Okay, so give me a second. Yeah, so it's complicated, but we're gonna start from the we'll try to find a function that we know the graph. Okay, so see x minus 3 squared. So give me a second. X minus 3 squared, right there. So we can get x minus 3 squared from the x squared by what? Translation, right? So original translation, I mean. So let me start from the graph of f of x. I mean f of x, which is x squared. Okay. So now, then, well, we have to follow that order, okay? So see that HT, stretching, shrinking, reflection, and then vertical translation, okay? Because the problem doesn't give us the specific, order of transformations. So we apply the horizontal HT, horizontal translation. Okay. So using HT, we can get x minus 3 squared from x squared by translate f of x h unit to the right. Right. So with f of x minus 3, then we got the x minus 3 squared. Is it? Okay. And then what? then we apply the stretching shrinking. You see that 2? You see? So to get 2 from here, we multiply f of x minus 3 by 2, right? So 2 times a function is what? Stretching, stretching the graph of f of x minus 3, right? By a factor of 2, right? So this is a stretching. The graph of f of x minus 3, okay? By a factor of 2. Okay. So now there's going to be, then what? We got 2 times f of x minus 3, which is 2 times x minus 3 squared. Okay. Keep in mind this, we're going to apply the transformation. Yeah, so here we apply the transformation in f of x. Okay, this step 1. In step 2, we apply the stretching that transformation into not f of x, no, but just the function what we got in previous step. Okay, f of x minus 3. So now we see the negative 2. That's the reflection, right? So we're going to apply the reflection. Okay. Reflection about the what? You just think of this. To get the negative 2 times x minus 3 squared, we need to put negative 2 outside the function. We just consider this one as a one new function, okay, holding 2 times f of x minus 3 is a one, one just function, okay? Then we need to put the negative sign in that function, right? It means a reflection about the x-axis. So negative 2 times f of x minus 3 is equal to negative 2 times x minus 3 squared. Okay. And now we apply, you see that? Now what is this? Fourier translation. So through the Fourier translation, we got plus 4, right? So we Fourier translation, negative 2 times f of x minus 3 plus 4, that is equal to what? Negative 2 times x minus 3 squared plus 4. Okay. So now we express, actually this is y, right? That's the equation of function for the problems, this one. So finally we express that function in terms of f. You see that? In terms of f of x. Okay, now we're ready to plot the graph for each steps. This is x-axis, your y-axis. Okay, so starting from the graph of f of x. Okay, this is the graph of f of x here. Excuse me. Now what I'm going to do, we translate the graph of f of x to the right, 3 unit. Okay, 0, 1, 2, 3. Okay, so give me a second. Then what? Excuse me. And then we're gonna stretch the graph of this. By the way, this is f of x minus 3, right? So we're gonna stretch, excuse me, the graph of f of x minus 3 by a factor of 2. So then we got this. I mean, if you want to plot the graph more accurately, just figure out the points on the order the pair of the points on the graph of 2 times f of x minus 3 at a couple of x value, okay? 2 and 4. When x is 2, give me a plug in 2 into what? 2 times x minus 3 squared, then we're gonna get 2, right? So there's 2. There's a 2. And when x is 4, we're gonna get 2. So now here, okay. So anyway, so that's the graph of the 2 times f of x minus 3. Okay. And now we reflect the graph of 2 times f of x minus 3 by about the x-axis. So we got this. It's gonna be this one. Right? Okay. Now, and then this is a negative 2 times f of x minus 3. So when x is 2, we're not gonna get 2, but we're gonna get negative 2 right here. When x is 4, we're gonna get negative 2. Okay, and then we do a vertical translation. Or move shift the graph of negative 2 times f of x minus 3 upward 4 unit. Okay, so then that point moves upward 4 unit, right? 1, 2, 3, 4. Okay, so it must be like this. Let's see. 2, yeah. Okay, so it must be like this. Okay, so that's going to be graph of the uh, negative 2 times x minus 3 squared plus 4. Okay, so that's the negative 2 times f of x minus 3 plus 4. Okay, so now this kind of problem will be on yeah, definitely on test, and then homework, same quiz. Okay, so the if you understood this step, yeah, that you got transformations. Okay, so let's see one more problems. Okay, B. So see, y is equal to 4 minus 2 times square root of x plus 1. Okay, so guess what? We start from the what? The square root function, right? Because the square root is involved. Okay, so starting from f of x is equal to square root of x. Okay, give me a second. All right, so first we apply the ht, right, to get the x plus 1. Or can say, because following the order of transformation, you gotta apply, ht first. So we got f of x plus 1. It's going to be square root of x plus 1. That's the one. Actually, the translation of the 1 unit to the left, not like, because x plus 1. Okay. And then what? We apply the stretching or shrinking, and then reflection, stretching. Okay. Then we got 2 times f of x plus 1, which is 2 times square root of x plus 1. Okay. And then we apply the reflection about the x-axis. Okay. So negative 2 times f of x plus 1 is equal to negative 2 times square root of x plus 1. Okay. And then we apply the vertical translation. So negative 2 times f of x plus 1 plus 4, which is negative 2 times square root of x plus 1 plus 4. Why we add a plus 4? Because you see that 4 is right there. Now, okay, so we plot the graph of the y. Okay, so this is a graph of f of x, by the way, and then we translate the graph of f of x to the left 1 unit. So it's a negative 1. So we're gonna get this. Okay, this is a graph of f of x plus 1. Okay, and now we stretching by factor of 2. See that? By factor of 2. This is a factor. Okay, so it means that the graph of f of x plus 1 will be elongated, right? So we got this. Okay, that's gonna be 2 times f of x plus 1. Okay, and then we reflection about the x-axis. So we got this. That's gonna be negative 2 times f of x plus 1. And then we translate this graph vertically upward. I mean upward 4 unit. Okay, so this point move upward 4 unit. 1, 2, 3, 4. So we got this. Okay. So that's going to be a graph of negative 2 times f of x plus 1, 1 plus 4. Okay. All right, so let's keep writing this. Now, what are you going to do? And then we are going to cover the symmetry. Oh, before doing that, so let's see one more problems. Give me a second. Okay, this is exercise problem in the textbook. Okay, so let's see problem 43. Okay, so see the graph of y. I mean, here's the question: is this: write the equation of each graph after the indicated transformation. So problem 43, as you can see that the order of transformations are specifically mentioned in the problems, right? So you have to follow that orders. So the graph of y absolute value function, right, is reflected in the x-axis and it's stretched by a factor of 3. And that translates 7 unit to the right and then 9 unit onward. Okay, let's figure out the function, the graph, after transformation of that absolute value. Okay, so see now the exercise problems number 43. Okay, so y is equal to absolute value of x is given. Okay, so what they says is reflect in the x-axis. Okay, okay, then we got this. Let me use a function notation instead of y. Okay, so let me use f of x instead of y. Okay, okay, let me use this one. Give me a second. So then if you reflect the graph of f of x about the x-axis, we got this minus f of x, which is a negative absolute value of x, right? And then this is stretched by a factor of 3. By a factor of 3, then we got this negative 3 times f of x, which is a negative 3 times absolute value of x, right? Okay. And then we translate 7 unit to the right. Translate 7 unit to the right. That's the original translation, right? And then what? We have to the replace x by what? X plus 3, x minus 3, right? And that's going to be negative 3 times absolute value of x minus 3. And then we apply, this problem says that 9 units upward. Okay, so this is a very good translation. Negative 3 times f of x minus 3 plus upward 9 unit plus 9, which is negative 3 times absolute value of x minus 3 plus 9. Okay, okay. So let's figure out graph of this one. So see, I think I need, here's y-axis, x-axis. The graph of the absolute value of x is this, right? Okay. Right. So this is graph of f of x. And we reflect the graph of f of x about the x-axis. So we got this. Right. Right. This graph of negative f of x. Okay. And then we stretch it by a factor of 3. Right. Then we got this. Give me a second. We're gonna get this. This is a negative 3 times f of x. Okay. All right, and then we translate a 3 need to the right, right? So here's a 0, 1, 2, 3. Here's 3, right? Okay. We got this. Okay. That's the negative f of x minus 3 times x minus 3. And then for moved upward 9 unit, you say here's 9. So we get this. Okay. So that's the negative what? 3 times f of x minus 3 plus 9. Okay. Let's see. All right. So the that problems I told you the order of transformation was specifically mentioned, right? So given, right? So I follow that order. Okay. So now let's see symmetry. Let me cover symmetry. Okay. So 5 symmetry. So symmetry is this. The if f of x, I mean f of negative x, okay, negative is equal to f of x, okay, then f of negative x is equal to f of x. And then what the f of x is an even function. Okay, and the graph of f of x is symmetry about the y-axis. I mean, it makes sense. What do you mean? So the f of x is even function. It means that f of negative x is equal to f of x. But what about the graph of f of x? That's symmetry about the y-axis. You see that f of negative x. So when I introduce the reflection about we saw the reflection about the right there, reflection about the y-axis right there. So if the f of x is equal to f of negative x, it means that their graph are identical. Does it make sense? Then what circumstance we're gonna get, that case f of x is equal to f of negative, I mean their graphs are identical. The graph of f of x must be symmetry about the y-axis. That's the only case we're gonna get their graphs are identical, right? So the one of the popular example is what square function. Think about this: f of x equals x squared. You see, this is the symmetry about the y-axis, right? Because when you reflect the graph of x squared and parabola about the y-axis, we're gonna get exactly the same shape of the graph of the x squared. So this is the even function. Then let's see if this is really satisfied that condition. Okay, so we're gonna start from the f of negative x. This is gonna be what? Okay, we'll assume the f of x is defined by the x squared. Okay, so let's try to find out f of negative x, which is negative x squared, right? Which is x squared. That's the f of x, right? So start from the negative f of negative x and end up with what? F of x. So I algebraically proved that this is an even function, I mean symmetric about the y-axis. Okay. What about the other function we mentioned there, right? If f of x negative x is equal to negative f of x, okay, then what? F of x is an other function. Okay, it's an other function, and the symmetry, the graph of f of x is a symmetry about the y-axis. Symmetry about the origin, sorry. Okay, so remember the symmetry about the origin right here. So if the graph of f of x is symmetry about the origin means the graph of f of x and the graph of the negative f of negative x is identical. Then we say that f of x is symmetry about the origin. Okay, so what's the example? What do you feel I mean, it's too much abstract, right? So we'll see, let me give a specific example, which is x cubed. Okay, so f of x is equal to x cubed. This is symmetry about origin. How? Because let's figure out the graph of origin, okay? I'm going to reflect the graph of the y-axis first, okay? And then I'm going to reflect the graph of, this is the f of negative x, okay? And I'm going to reflect the graph of negative x about the x-axis. Okay, well, we're going to get this. So this is a negative f of negative x. We see that graph of f of x is identical to the graph of negative f of negative x. So f of x must be symmetric about origin. Okay. Let me prove it by algebraically. Okay. So we start from f of negative x. This is it. Turns out. I mean, by the way, okay. You may just confuse with this one, and then negative f of negative x equals f of x. Think about this. F of x is equal to negative f of negative x. If we just sub multiply by negative one on both sides, we get this. Negative f of x is equal to f of negative x. Right? So this expression exactly same as that expression, isn't it? Right? Because the only thing, different thing is the where the negative sign is attached. Left hand side, right hand side. That's the difference, right? So now, so start from f of negative x. This end up with the f of x. That means the function is even function. Start from f of negative x, it ends up with the negative f of x. That means f of x is other function. Okay, so f of negative x is negative x cubed, which is negative x cubed, right? Okay, it's trivial, right? So this is equal to negative f of x. So it turns out that, yeah, x cube function is other function. Okay, I proved that algebraically. And then what's those graph look like? This one. Okay. So now see. Let me give me a second. Let's see example 8. Okay. So let's see example 8 in the problem A. So just one problems. Right. So discuss the symmetry of the graph of each function. So yeah, let me take a look. Yeah, let me see A. Yeah, see. Okay, A is fine. Let's see. So example 8. So A f of x is equal to 5x cubed minus x. Okay. So then what? We start from f of negative x. So to figure out whether or not the f of x is other function or even function, other function, even function, or neither, you have to start from f of negative x. Okay. So now then this is equal to 5 times negative x cubed and then minus x. Right? So now this is equal to negative 5x cubed and then plus x. So definitely this is not this is not equal to the graph f of x, right? Because f of x is positive 5x cubed, but we got negative 5x cubed. So now then the but now we try to figure out whether or not this is equal to negative f of x. Okay, so try to factor out negative sign. So negative 5x cubed and then minus x. So that is equal to what? You see that 5x cubed minus x, this is exactly the same as the what? Definition of f of x. So we got to say negative f of x. So starting from the f of negative x, we got negative f of x. It means that this function is other function. Okay. So that's for today. Okay. We're gonna see maybe a couple of the online homework problems next time in 2.3. Okay, and I'll move to 2.4. Okay, that's for today. Thank you.